So welcome back, and we're carrying on with our study of sequences and series, and in particular with geometric sequences at the moment. Right, let's dive straight back in and let's take a look at these questions. So they're also kind of real life examples that involve geometric sequences. All right, so at the end of the first year, all right, a tree grows 1 meter in its first year. So that's how tall it is at the end of the first year. Each year thereafter, it grows by 18%. How tall will it be after 10 years? Right now, so to grow something by 18%, we're going to multiply it by 1,18. And just to emphasize, this number over here is actually the same as 118%. So the tree grows, we're finding 118% of the original of the one. Okay, in the next year, and that'll obviously just be 1,18 meters at the end of year one, right? But at the end of the next year, it's now grown by 18% of that. So we're going to take our 1 times 1,18 and 1,18, and we're going to multiply it by another 1,18. Right, and what we would want to do with these types of questions, we want to write down a few terms, just as many as we need to see what we're dealing with. Well, this is definitely a geometric sequence. All right, we know A is 1, and we know that R is 1,18. That's what we're multiplying by to get from one term to the next. How tall is it after 10 years? Well, we want the 10th term, remembering our formula. AR to the n minus 1. So in fact, T10 is just going to be 1,18. So it's 1 times 1,18 to the power of 9. Let's have a look at what that is. 1.18 to the power of 9, and we get 4,43 or 4,44 meters. Okay, the next one's not dissimilar at all, right? A virus grows by 10% per year. So initially there's 200 infections. That's right now. But after 1 year, there'll be 200 times 1,1. 1,1, that's 110%. This number over here is 110%. So we're growing it by 10%. All right, we've got the 100%, which was the original, and then an extra 10%. That's how many infections there will be after 1 year. After 2 years, this number, which is 200 times 1,1, that will now grow by 10%. And to grow it by 10%, we're going to multiply it by 1,1 again. Right, so once again, and the next one will be 200 times 1,1 times another 1,1 times another 1,1. So in other words, 1,1 cubed. So we are looking for the 12th term, T12. So T12 is just going to be 200 times by 1,1. That's A. All of that is A. There it is, A. Then we're going to multiply by 1,1 to the power of 12 minus 1. So in other words, the power of 11. Okay, and as we've done previously, just to save time here, I'm just going to go 200 times 1,1 to the power of 12 when I put that into my calculator. 200 times 1,1 to the power of 12. Okay, and we get 627,6. Because these are numbers of infections, we're probably just going to round this to the nearest whole number, so 628. Right, 628 infections. Okay, and then there's one more. Remember, if you haven't done any of these and you want to try them, then by all means pause the video and just try them. Right. So after 1 year, the car is worth 350,000 Rand, but after 1 year, it will have lost 20% of its value. Now, if something loses 20% of its value, of the 100%, what percentage is left? That's absolutely right. 80% will remain all right, after each year. 80% of the previous year's value will remain after each year. Now, what do we multiply by to find 80%? 80% is just 0,8. All right, so let's take a look. At the end of the first year, it will be worth 350,000 Rand times 0,8. Right, we can work that out as a number, right? But it's actually almost easier to see what's going to happen now. Now that number, which is 350,000 times 0,8, that's what it's worth at the end of year one. To work out what it's worth at the end of year two, we must take 20% off it. In other words, we must find 80% of it, all right? And notice that this is what keeps on happening. So at the end of year two, it's actually worth 350,000 times 0,8 squared. That number needs to be multiplied by 0,8 to take another 20% off it. I hope it makes sense. It always makes sense. 350,000 times 0,8 cubed. Okay, so this is term 1, term 2, term 3. We want term 8. Term 8, remember, is just AR to the n minus 1. So term 8 is actually just going to be 350,000 times 0,8. That's my A value. All right, there it is. I'm just going to underline all of that. That's A. R, we can clearly see R is 0,8. So now I want to take my R value of 0,8 and I want to raise it to the power of 8 minus 1, in other words, to the power of 7. Okay, and my final answer, let's have a look. It's going to be 350,000 times 0,8, actually to the power of 8. There's 1 here and another 7 there, all multiplying. When we have repeated multiplication, we have powers. Okay, so the power 8. Okay, and we get 5, 8. Okay, this is, so we get 58, 720 and 26 cents. 58, 720 and 56 cents. With money, we always round to the nearest cent. I'm just going to check myself on that. There it is. Okay, so we round to the nearest cent. Okay, right. Now, there are two questions here that are tricky. Okay, they're meant to be tricky. We don't only want to do easy questions. We want to try and equip you to do difficult questions. Right, let's look at number 30 is reasonably challenging, but I'm going to give you a bit of a hint, and then I'm going to see if you can get there. Okay, so what it says, the first 3 terms form an arithmetic sequence. So those 3 are an arithmetic sequence. Okay, but the last 3 terms, these 3, form a geometric sequence. And the question asks us to find x and y. Now, big idea here. If we're trying to find 2 variables, can anyone remember what we often do? Absolutely, impella. We try and find 2 equations and we try and solve them simultaneously. Okay, now, in your notes, if you remember, we've got those results in boxes where we're not using formulas, we're just using the sort of big idea behind what it means for something to be arithmetic and what it means for something to be geometric. Pause the video, have a go at this, see if you can find out what x and y are. Right, let's take a look. What we know from the fact that the first 3 are in arithmetic sequence, we know that x minus 2 must be the same as y minus x. Okay, that is an equation. Just using the fact that those first 3 form an arithmetic sequence, the difference, t2 minus t1 must be the same as t3 minus t2. Right. Let's get y on its own here, and we're doing this with a view to solving these equations simultaneously. So what I'm going to do is I'm going to add x to both sides. Remember equations, remember the scale. Y is the same as 2x minus 2. This is still equation number 1. Okay, now let's make another equation. Let's make an equation with the blue information. We know that this ratio y divided by x must be the same as this ratio 9 divided by y. Here is a second equation. Right, now this one, remember, when we've got two fractions equal, the top of the one times the bottom of the other is the bottom of the one times the top of the other. So y squared is actually the same as 9x. That's equation number 2. Now we're going to solve these two equations. They are not easy to solve by elimination because we haven't got the same number of y's or x's. But what we can do is we can substitute. We can take this value for y and we can put it in here. Okay, so let's do that. So what it's going to be, it's going to look like this. Y squared equals 9x. But what is y? Y is the same as 2x minus 2. Now I'm going to say halala. And the reason I'm saying halala, now we've only got one variable. This is a quadratic equation. We need to square it out properly. Don't make the mistake of just squaring that and squaring that. Remember the pattern. We square that. Then we multiply these two things together. We get negative 4x. Quadra, we must also multiply by 2, so negative 8x. Then we're going to add 4, which is negative 2 times negative 2. If you need to write the two brackets next to each other and take an extra line, no problem. Much better to do it slowly and get it right than to do it fast and get it wrong. What we now get is 4x squared. I'm going to subtract 9x from both sides. Plus 4 equals 0. This is a quadratic equation. We're going to try and factorize it. So we're just coming up here now. And we're going to get in the one bracket. What we do know for sure. We know for sure that the two signs must be the same. Right? And they must both be minus signs. And the only way we can get a positive product is to either have two minuses or two pluses. If the signs are the same, because this is a plus, then they will both be what that one is. Right, now this is just a little bit of playing around. We can use the quadratic formula, but this actually factorizes with a 4x here and an x here. Right, now I want to make 17. If I put 4 here, I'm going to get 16 from there. And if I put 1 here, I'm going to get 1 from here. Okay, so let's do that. So this is going to be 1. And if we check it, negative x, negative 16x. And we've still got the plus 4. So now we've got our answers. X is a quarter, or y is 4. Or x is 4, sorry. Now remember, we're actually solving simultaneous equations here, so we need values for y. Each of these values for x is going to give us a value for y. Now, 2 lots of a quarter is a half. I'm doing this over here. You can put it into a calculator if you need to, but you shouldn't need to. A half minus 2 is negative 1.5. If x is 4, 4 lots of 2, 8, take away 2 is 6. So now we've got two possible solutions, and notice I'm grouping them like that. We might want to even write them as ordered pairs, but let's just look at the final answer here. Let's look at what it looks like. If x is a quarter, then this thing is going to look like this. 2, 1 quarter, negative 3 over 2. All right, and then 9. Okay, now, if we look at this divided by this, or this divided by this, we're trying to check, is this kind of arithmetic? Are the first 3 arithmetic? Let's just check this. We'll do it with a calculator. Let's just check. If we take 2 and we subtract a quarter, we get 7 over 4. All right? And if we, sorry, not 2 subtract a quarter at all. If we take a quarter, subtract 2. So the second term minus the first term. I'm trying to check if these first 3 are in arithmetic. Okay, quarter minus 2. We get negative 7 over 4. Let's try taking this one minus this one. Okay, to see if we still get negative 7 over 4. So negative 3 over 2 minus a quarter. And we get the same. So those 3 are in arithmetic sequence. Now let's just check. If we take negative 3 over 2 and we divide by the term before it, we're looking at these last 3 terms, we divide by the term before it, so we divide by a quarter, we get negative 6. Now let's take this one divided by this one and see if we also get negative 6. So 9 divided by negative 3 over 2. We get negative 6. So that is definitely a correct possible answer. The other one is to go 2, 4, 6, and 9. 2, 4, 6, and 9. Now we definitely don't need a calculator to check this one, because 2, 4, 6 is definitely arithmetic, and 4, 6, 9 is geometric, because if you take 6 divided by 4, 6 divided by 4 is the same as 3 divided by 2. All right, if we simplify that, and 9 divided by 6, also 3 divided by 2. Okay. The next one is really, really quite tricky, okay? This tells us that these are arithmetic, and we are asked to show that these are geometric. Now, if these are geometric, we need to show that y divided by x is the same as z divided by y. Okay, so we want to end up with y divided by x equals z divided by y. Okay, which is also the same as showing that y squared is x times z. Remember, if we multiply the top and the bottom. So now that's what we need to get to. But we need to start with this. This is what we are told. Now, what equation can we make if these 3 things form an arithmetic sequence? Okay, we know that minus that is the same as 1 over y minus z minus 1 over 2y. All right, now, from here, it's just algebra. We need to add these fractions. We've got an equation, so we can do the same thing to both sides. And we want to try and get from here to here. I'll ask you to pause the video, try. It is tricky, so don't spend too long on it. And then we'll take a look. Okay. We're going to add these 2 fractions, so we're going to have a common denominator of 2y into y minus x. This one, we need to multiply the 1 by y minus x, and this one, we need to multiply the 1 by 2y. We're going to do exactly the same on this side. We get 2y, and we get y minus z. This one, we're going to multiply the 1 by 2y, so we've generated an equivalent fraction. And this one, we're going to multiply by the negative by y minus z. So just be careful, because there's a bracket that we needed there. This one becomes negative y minus x over 2y. And this one becomes y minus z. All right, 2y minus y is y plus z. And here we've got 2y, y minus z. All right, and I've realized that I've actually made a mistake here. I've left off this y minus x. Okay, now, if we multiply both sides by 2y, it will divide out. Okay, so we can make that simplification. Now we've got these two fractions equal, and remember that if we multiply the top by the bottom and the bottom by the top, right, what we're going to get here, okay, we're going to get a negative y squared. I'm going the top left to the bottom right, negative y squared. We're going to get a negative xy. We're going to get a positive yz. And we're going to get we're going to get a positive yz, and we're going to get a positive xz. On the other side, we're going to get a y squared. We're going to get a zy, a yz. We're going to get a negative xy. And we are going to, lastly, we're going to get a negative xz. Okay, now if we look at all of this, and as I said, this is tricky, it's just algebra though. If we add an xy to both sides, those disappear. If we subtract a yz from both sides, those disappear. If we now add a y squared to both sides, we will get 2y squared. All right, and if we add an xz to both sides, we're going to get 2xz. If we now divide both sides by 2, we get that, and therefore we can write it like that, and therefore x, y, and z are in a geometric sequence. Geometric sequence. Okay, really tough question. But the ideas are actually quite simple. The algebra is horrible, okay? Being able to add algebraic fractions is what's probably going to let one down there if one can't do that. All right, we're going to stop there. And in the next lesson, we're diving into a whole new section of this topic, which will be really exciting. Looking forward to seeing you. Bye now.